So welcome to my channel. Am I audible? Can anyone inform? Am I audible? Okay then. Okay, let us start this topic. So in this numerical problem, we have to write the differential equations governing the mechanical system shown in the figure. Actually, it's not figure 1, it is only figure. It's not figure 1. Okay. And draw the force voltage and force current electrical analogous circuits and verify by writing mesh and node equations. It's a very small numerical problem. I think it will take hardly half an hour to solve this numerical problem. So this is a given system. So you can see here in this mechanical translational system, there are two masses M1. I will take the laser. There are two masses M1 and M2. Two masses are there, and displacement has been mentioned. At M1 displacement is x1, at M2 displacement is x2, and to M1, okay, so you can see here there is a frictional element B1 and there is another frictional element K1, and this is okay, and you can see frictional element B2 and K2 here. Okay, so here to this mass M1, okay, so there is no applied force here. Applied force F of t is at M2, mass M2. Applied force is not there at M1. Only opposing forces are there. Opposing forces are, one force is due to mass, one force is due to V1, and one force is due to K1. So one force is due to M1, another force, opposing force is due to B1, another opposing force is due to K1. And here B1 is the frictional force, okay, so which is in between M1 and M2, okay, in between M1 and M2, and K1 is also in between M1 and M2. So this is M1, this is M2. So the opposing force due to this elastic element and opposing force due to this frictional element, okay, both the opposing forces are between both M1 and M2. Okay, so just draw it. As soon as you complete, inform. Okay then, so we know this is our mechanical translational system. So we have to draw the free body diagram for this. So here, since two masses are there, we can draw two free body diagrams. So let us see how to draw them. Okay. So since there are two masses, so definitely you can write two force balance equations. So let us consider mass 1. Already in the question itself, they have mentioned the displacement x1 at mass 1. So you can write x1 and velocity at mass 1. Let us assume it as v1. Velocity is not mentioned, but we will assume it as v1. Displacement is mentioned, so write displacement x1 and velocity v1. Let us draw a rectangular box and write m1 inside it. And what are all the opposing forces at m1? I'll just copy the diagram here so that we can compare. So opposing forces at m1, we can see one force is due to the mass itself, m1, another opposing force is due to b1, another opposing force is due to k1. So the opposing forces here are fm1, fb1 and fk1. These are the opposing forces. So just draw the free body diagram and mention in the comment section as soon as you complete. Now write down the force balance equations. We can write down the force balance equations. What is Fm1? What is Fm1? Fm1 is equal to m1 d square x1 by dt square. Fb1 is b1 into d by dt of x1 minus x2. Why? Because b1 is between mass 1 and mass 2. That's why d by dt of x1 minus x2. Fk1 is equal Fk1 equal to k1 into x1 minus x2. Why? Because k1 is between mass 1 and mass 2. So you have to consider the differential displacement, difference of the displacement. By Newton's second law, the sum of the opposing forces must be equal to sum of the applied forces. There is no applied force at mass 1, therefore 0 is equal to sum of the opposing forces. What are all the opposing forces at mass 1? Fm1 plus Fb1 plus Fk1 are the opposing forces. They are the opposing forces. So just write down m1 d square x1 by dt square instead of fm1. Instead of fb1, write down b1 d by dt of x1 minus x2. Instead of fk1, write down k1 into x1 minus x2 equal to 0. This is our equation 1. If you complete, just mention so that I can proceed. Note it down so that it will be useful to you. So I hope you have completed. I will just okay. So we have got the differential equation. This is our differential equation. Consider it as equation 1. Now let us proceed. Now let us go to let us draw the free body diagram of mass m2. Okay. So in order to draw the free body diagram of mass m2, let me copy the I will just copy the actual mechanical system. Okay. So this is our given mechanical translational system. So let us see the opposing forces at M2. So at M2, what are all the opposing forces? One force is due to the mass itself, that is Fm2. Another force One force is due to the mass itself, that is Fm2 is the one of the opposing force. There is applied force F of t. Okay, and one more opposing force is due to this frictional element B2, that is Fb2. Now one more opposing force is due to this elastic element K2, that is Fk2. Okay, and one more element is there, that is Fk1. Okay, one more opposing element. So force due to K1, opposing force due to K1, that is one of the opposing force. Another force due to B1. Okay, another force due to B1, that is Fb1, that is one of the opposing force. So total how many? Fb1, Fk1, Fm2, Fb2 and Fk2. Okay, so total there are 5 opposing forces, one applied force, that is F of t. And here I didn't mention that. Okay, so these are the opposing forces. So actually I must also draw the what to say, this displacement and velocity. Somehow it has been deleted. I will just add it and I will show it to you. Simply I just want to copy this and here, and instead of x1 I want x2. So what I will do is I will just take this 2, let me check. So here it should be x2, not x1. So I'm not satisfied with this. I will take another 2. You people can draw the free body diagram and proceed. If you get the answers, this 2 is okay for me. Two and more. So this is it. In the earlier diagram, somehow the displacement and velocity terms were deleted. I didn't notice that. I have added it. So something is wrong here. It's okay. So I hope you have drawn, even though it's not here in my diagram. I hope you have drawn. I will just save it. So this is it. I hope you have completed this also. So these are the opposing forces. Total 1, 2, 3, 4, 5. 5 opposing forces are there. One applied force is there at mass m2. So displacement is x2 and velocity is v2. Okay, at mass m2, displacement is x2 and velocity is v2. So let us see the force equations. Opposing force and of course applied force is f of t. That's it. So opposing forces are Fm2. So what is Fm2? Fm2 is equal to m2 d square x2 by dt square, And what is FB2? B2 d by dt of x2. FB1 is B1 d by dt of x2 minus x1. Why? Because B1 is between mass 1 and mass 2. So Fk2 is K2 x2. And similarly Fk1 is K1 into x2 minus x1. So why x2 minus x1? Because K1 is between mass 1 and mass 2. Now apply Newton's second law at mass m2. If you apply Newton's second law at mass m2, the applied force F of t should be equal to what? Opposing forces, sum of the opposing forces. So sum of the opposing forces are Fm2 plus Fb2 plus Fk2 plus Fb1 plus Fk1. So now instead of Fm2 write m2 d square by dt square x2 plus, instead of Fb2 write b2 dx2 by dt, okay, plus here this is d, it is looking like a, but this is d, okay, dx2 by dt plus fk2 is k2 x2, fb1 is b1 d by dt of x2 minus x1, fk1 is k1 x2 minus x1 equal to f of t. That is considered as equation number 2. Okay, considered as equation number 2. So we have got two equations, only two masses are there. We have got two equations. Now what we have to do? We can replace this displacement with velocity. So what is the relation between velocity and displacement? Dx by dt is equal to v. So x is equal to integral of v dt, and d square x by dt square is dv by dt. So write down the relation between this velocity and displacement. Relation between velocity and displacement, you just write it down. Relation between velocity and displacement, these three equations. Okay, these are the, my cursor, it won't listen to me. Write down these three equations. Okay, write down these three equations and substitute these three equations in equation 1 and 2. Substitute these three equations in equation 1 and 2. Is my voice not clear? Can anyone inform? Someone has mentioned my voice is not clear. Let me check. Substitute these three equations in equation 1 and 2. Yeah, there is some disturbance in my voice. Is my voice not clear? Can anyone inform? Someone has mentioned my voice is not clear. Let me check. So you just mentioned once again if my voice, is there any disturbance in my voice now? There is no voice. So you just mentioned once again if my voice, is there any disturbance in my voice now? My voice is clear now. You can see I have also logged in with another channel. So my voice is clear now. Maybe I did not fix the mic properly earlier. Now it is okay. Yeah, now it is okay. Okay then. Now where were we? So here we have to replace the displacement terms with respect to the velocity terms. So if you replace it, you will get these equations. Equation 1 will become equation 3 and equation 2 will become equation 4 simply. Okay. So if you want, I will just copy equation 1. This is our equation 1. So see here, equation 1 is what? m1 d square x1 by dt square. D square x1 by dt square is what? dv1 by dt. So m1 dv1 by dt you have to write plus. Okay, m1 d square x1 by dt square you have to replace it with dv1 by dt. So m1 dv1 by dt plus b1. b1 write it as it is. D by dt of x1 is v1. D by dt of x2 is v2. So v1 minus b1 into v1 minus v2 plus k1 write it as it is. Okay, x1 is equal to what? Integral of v1 dt. So instead of x1 write integral of v1 dt. x2 means integral of v2 dt. Instead of x2 write integral of v2 dt. So I have taken integral common. I have written v1 minus v2 of dt. Integral. Okay, after integral I have written v1 and v2 within brackets of dt equal to 0. That is my equation 1. So equation 1 is modified to equation 3. Similarly, equation 2 is modified as equation 4. How it has been modified as equation 4? Let us see. So see here, equation 2. Equation 2 is what? m2 d square x2 by dt square. So m2 write it as it is. Instead of d square x2 by dt square, what you have to write? dv2 by dt plus b2 write as it is. I will take laser. Okay, b2 write as it is. dx2 by dt. What is it? dx2 by dt v2. Next plus k2 write as it is. x2 is what? Integral of v dt. X is equal to integral of v dt. x2 is equal to what? Integral of v2 dt. Okay, instead of x2 write integral of v2 dt. Next b1 plus b1 write b1 as it is. D by dt of x2 means v2 minus d by dt of x1 means v1. Okay, so v2 minus v1 plus k1 write as it is. What is x2? Integral of v2 dt. What is x1? Integral of v1 dt. So integral of v2 minus v1 dt is equal to f of t. You just write it f of t as it is. Okay, so equation 2 is modified as. So this is our equation 2. Okay, so this has been modified as equation 4. So this equation itself, it has been modified as equation 4. Okay, simply we have replaced displacement terms with respect to the velocity terms based on their relation. So you can note down equation 3 and 4 if you complete in form. Okay, now I hope you have written. I hope you have written the equation 3 and 4. Now let us go for force voltage analogous circuit. So in order to draw the force voltage analogous circuit, first of all we must check how many masses are there in the given system. We already, I hope you remember, there are two masses. So in force voltage analogous circuit there will be meshes. How many meshes will be there? You can mention in the chat box. Okay, how many meshes will be there? Can anyone mention in the chat box how many meshes will be there? One mesh, two mesh, or three meshes? How many meshes will be there? There are two masses, so how many meshes? There will be two meshes will be there. Okay, I'm sorry, two meshes will be there. Okay, so now whatever elements are there here, what are all the elements in the given in equation 3 and 4? What are there? M1 is there, V1 is there, B1 is there, V2 is there, K1 is there. Write down all those elements. Write down all those elements in a sequence. You can write down. Next, M2, B2, K2 did we write? We did not write. So K2 and what else is left over? And F of t. Okay, I hope I have covered all. M1, V1, B1, V2, K1, M2, B2, K2 and F of t. These are our elements. So 1, 2, 3, 4, 5, 6, 7, 8, total 9 elements. 1, 2, 3, 4, 5, 7. I have written only 8 elements. Did I miss anything? Did I consider V1, V2? I have considered V1, V2, M1, M2, K1, K2. I have considered K1, K2, B1, B2. I have considered B1, B2. Okay, and F of t. Yeah, total 9 elements I have considered. So write down all the elements and write their analogous electrical terms. Okay, so force voltage analogy. If you know force voltage analogy, you can write down their respective analogous terms. So F of t, analogous of F of t is E of t, or you can write V. Okay, analogous of velocity is current. Analogous of mass is inductance. Analogous of spring is 1 by C. Okay, reciprocal of capacitance we can say. Analogous of frictional element, B is resistance. Okay, so these are the analogous elements. So you just write down these elements from the force voltage analogy table. Okay, so if you know the force voltage analogy table, then you can write down this. So write down quickly. Now so I hope you have completed. You have written all those elements. It won't take much time to write down these elements and to write down the analogous elements. Now let us design the circuit, electrical circuit. I have already designed here, but I will take an empty page, and it's better if I change my cursor. Yeah, I will take an empty page and I will just copy this image. So this is my mechanical system. For this mechanical system, I have to draw the electrical force voltage means electrical system. Okay, force voltage analogous circuit. So to draw the force voltage analogous circuit, I will just expand it. To draw the force voltage analogous circuit, since there are two masses and since there are common elements between these two masses, so we can draw two meshes. I will erase and I will change the cursor and I will see. Okay, I have connected some another cursor. Okay, I have changed my mouse now. Let us see. Okay, so this is it. So let us draw two meshes. Let us assume this as mesh 1, mesh 2. Okay, so you can write down here. You can write down here mesh. Sorry, I didn't write properly. Mesh 1 and mesh 2. You just write down mesh 1. Now I am unable to write. Mesh 1. Oh, this is also behaving like that only. You people write down mesh 1 and mesh 2. I am unable to write with my mouse. This is mesh 2. I am writing M2. I can't even write that 2. So a mesh 2. You just write mesh 2. So now, what are the common elements between mesh 2 and mesh 1? B1 and K1. If you remember, here of course I have shown you here mechanical system. I am showing you here K1 and B1. They are the common elements. So what is K1? K1 is 1 by C1. And what is B1? B1 is R1. Okay, K1 is 1 by C1 and B1 is R1. So 1 by C1 means the capacitor should be connected in series to the other element if there is another element. So the resistor and capacitor, they should be connected in series. Okay, resistor and capacitor, they should be connected in series. So you must always draw the meshes with pencil so that you can erase it. Okay, so I am erasing this. This whole term has gone. It's okay. This is it. Here what I should draw? I must draw a capacitor. Since it is 1 by C1, that's why capacitor should be in series with the resistor. So this is my resistor. So I'm just erasing this mesh 1, mesh 2. You people write it down. Mesh 1 and mesh 2. So I'm going to draw the resistor here. Again it has gone away. This is my resistor. So this is C1. This is R1. Okay, that's it. Now, what are all the elements that are connected to mesh 1? This is mesh 1. Only one element, that is M1. What is M1? M1 is L1. You can mention in the chat box if you are able to follow. So only M1 is connected to mesh 1, that is to mass 1. So I can erase this. Okay, and I can draw an inductor here. So I will put a line here. So here what I can do is, I can draw an inductor now. Draw an inductor here. So what is this? L1. Okay. Next, what are all the elements that are connected to mass 2. Common elements between mesh 1 and mesh 2 are over. Now only elements connected to mass 2. So applied force is there. So E of t. So the elements which are in mesh 2, which are connected only in mesh 2. So what are all the elements? One is E of t. So you can draw a circle. You can mention minus and plus or minus, your wish. You can write anything. Plus minus or minus or plus. No need to draw circle at all. Okay, no need to draw circle. I have drawn circle. If you don't want, you can put the positive terminal and negative terminal. This is my E of t. E of t. F of t, applied force, F of t is our E of t. After that, what is another element here? Another element is M2. M2, what is M2? M2 is L2, isn't it? M2 is L2. So draw an inductor. I am unable to draw properly. You people better, you people draw. My cursor won't, I don't know why it is. I changed the mouse, but it is not listening to me. I don't know the reason behind that. Again it has gone. So I will try. So draw an inductor. So this is my inductor, that is L2. Okay. After L2, what is there? M2 is over. Now what is there? Opposing force? B2 is there. B2. B2 means R2. So draw a resistor. R2. Next, what is there? Capacitor. That is K2. K2 is 1 by C2. 1 by C2 means capacitor should be connected in series to these elements. 1 by C2. So this is it. So this is C2. Okay. Now mention the mesh currents. In mesh 1, mesh current is I1. In mesh 2, you can assume either clockwise or anti-clockwise, your wish. The mesh currents, you can assume anything. And no need to follow after source, no need to draw inductor, no need to draw resistor and capacitor. This sequence, there is no need to follow this sequence. You can vary the sequence. You can draw any term first. You can draw capacitor here. After that, you can draw source. After that, you can draw inductor. Then you can draw resistor. Your wish. Sequence is not important. Only the thing that is important here is all these elements must be connected in series. Okay. This is it. I'm trying to draw this 2 properly so that later I can use it. So this M1 is mesh 1, M2 is mesh 2. So this is our electrical circuit. So I hope you have drawn. Yeah, I hope you have drawn this. I will just save it so that I will just save it. Now this is it. You can draw this. This may not be same. This is same. Yeah, this is same, isn't it? I have drawn as it is. I didn't expect that. I have drawn it as it is. Now you can write down the KVL equations. KVL, you apply KVL in loop 1, you will get what is the equation that you are going to get here. What is it? L1 d by dt of I1 Okay, plus R1. R1 is between both the measures, so R1 into I1 minus I2 plus 1 by C1 integral of I1 minus I2 dt. That's what you will get. That is equal to 0. Okay, that is the loop equation for mesh 1. For mesh 2, loop equation is you can start with any element. Okay, so here there is a source, so you can write E of t is equal to L2 d by dt of I2 L2 d by dt of I2 plus R2 I2 plus 1 by C2 integral of I2 dt plus R1 into I2 minus I1 plus 1 by C1 integral of I2 minus I1 dt. So these are the two equations that you will get from this circuit. So if you want, you can copy it down here. I will just show you. So these are the two equations for that circuit. Equation, consider it as equation 5 and 6. Now compare equation 5 and 6 with your equation 3 and 4. They should be similar. Okay, those two equations should be similar. So if you complete mention, if you have completed writing this equation, just mention. And we will go for force current analogous circuit. I hope you have completed. You might have completed. Okay, now let us go for force current analogous circuit. For that, we must write the electrical analogous elements for this mechanical translational system. So first of all, what we must do, from equation 2 and 3, write down all the elements from equation 2 and 3. Okay, write down all the elements. These are the elements f of t, v1, v2, m1, m2, b1, b2, k1, k2. Okay, and write their analogous force current analogy elements. I of t is analogous to f of t. Voltage is analogous to velocity. Okay, and capacitance is analogous to m1. 1 by r is analogous to b. 1 by l is analogous to k. Okay, so since you have b1, b2, you must write 1 by r1, 1 by r2. Since you have k1, k2, you must write 1 by l1, 1 by l2. Since you have m1, m2, you must write c1 and c2. Since you have v1, v2, you have to write v1, v2. So this v1 is velocity. Okay, this is voltage. Okay, right side term is voltage, left side term is velocity. Okay. So you can consider velocity, instead of writing v, you might have written it as omega, but we didn't write it as omega in our equations. That's why I have written v here. So if you want, at the earlier stage itself, instead of writing v, you can write omega. So just note down these analogous elements. Note down these analogous elements, and now we can draw the electrical circuits. I am about to conclude. Maybe within 5 minutes I will conclude this numerical problem. Okay. So I hope you have written these analogous elements. Now let us take a blank page and let us copy the mechanical system. So this is the given mechanical system. So now we have to draw the force current analogous circuit. So how many masses are there in this system? There are two masses, m1 and m2. So how many nodes will be there? You just mention in the chat box. How many nodes will be there? If you mention in the chat box, I will be coming to know that you are following the class. How many nodes will be there? 2 masses means 2 nodes will be there. 2 masses means there will be 2 nodes. So in your notes, you just mention, just put 2 dots, 2 nodes. Node voltages are V1 and V2. Okay, node voltages are V1 and V2. So in between mass 1 and mass 2, what are all the common elements? What are the common elements? Means the elements between M1 and M2 are B1 and K1. Elements between M1 and M2 are B1 and K1. So what is B1 and K1? B1 is 1 by R1 and K1 is 1 by L1. So 1 by R1 and 1 by L1 means both should be connected in parallel to each other. So in between V1 and V2, draw in between V1 and V2, draw a resistor and inductor. Draw a resistor and inductor parallel to each other. Draw a resistor and inductor parallel to each other. I have drawn a resistor. Now I will draw an inductor. Oh, this cursor is very sensitive. You people, irrespective of what I am drawing, you can do it. If you are able to follow, you just do it. Okay. So this is my R1. This is my L1. Now, what are all the elements that are only restricted to mass 1? Only connected to mass 1, M1. Only one element, that is M1. What is M1? Analogous of M1 is C1. Analogous of M1 is C1. So at node, okay, at node V1, what you have to do? You have to connect a capacitor C1. You have to connect a capacitor C1. So at node V1, directly just draw a line. And I am unable to draw with my cursor. You people draw it. Draw a line. Draw a capacitor C1. Okay, C1. Okay, just leave it. Now at node V2, what are all the elements that should be connected at node V2? At M2, what are all the elements that are connected? One is the applied force. Applied force is, analogous of applied force is current source. Okay, analogous of applied force is current source. That is I of t. Okay, current source. That is I of t. Okay, that is one element. What is another element? Another element is, one is applied force F of t, that is over. Now, what is another element? What is it? M2. What is M2? Applied force, opposing force due to M2. So, what is analogous of M2? That is C2. C2 means we must connect C2 in parallel with the another element that is connected to this node. Okay, it is C2. So, draw a capacitor parallel to another element. What is another element? Source is the another element. Next, what is the other element that is connected here? That is K2. What is K2? K2 means, analogous of K2 is 1 by L2. 1 by L2 means inductor should be connected in parallel to the another elements that are connected to this node 2. Okay. So, draw an inductor parallel to the other elements. So, draw an inductor. I'm about to conclude this topic, this numerical problem. Within 2-3 minutes, I will complete it. Okay, it is taking much more time to draw this diagram. L2 is over. Now what else is left over? B2 is left over. So analogous of B2 is 1 by R2. So now draw a resistor. Draw a resistor parallel to the other elements, because it is B2 is 1 by R2 is analogous to B2. Actually, there is no need for me to draw this diagram, but I am drawing it. Why? Because already it is there. I thought if I draw, it will be more clearer to explain step by step. Whoever is watching this video, they will be able to understand this concept properly. So this is R2. That's it. Our diagram is over. Electrical analogous circuit we have drawn. Now join other terminals, and you can draw an reference node somewhere, anywhere. They all the other terminal of these elements will meet at the reference node. You can draw a reference node and mention node voltage as 0 volts. Okay, you can draw a reference node and you can mention node voltage as 0 volts. You can do that. I am erasing this because I did not draw properly. Okay, you can draw a reference node. You can mention that as reference node. So this is it. This is our circuit. This is our force current analogous circuit. So I hope you might have already drawn before head of me, because I am drawing very slowly. So this is it. This is the circuit. And now you can write down the nodal equations at node 1 and node 2. What is the nodal equation at node 1? What is our node 1? What is the node 1 is V1. Nodal voltage is V1, isn't it? So this is our node 1. So node voltage V1. So what is the equation? There is a capacitor. So C1 into dV1 by dt plus R1 and L1 both are in parallel. So 1 by R1 into V1 minus V2 and 1 by L1 integral of V1 minus V2 dt is equal to 0, because there is no source connected to node 1. So that is it. That is one equation. So what about another equation? What is our another equation? At node 2 nodal equation or applying KCL at V2. So what is it? There is there is a source I of t. So I of t is equal to there is C2 capacitor, C2 into dV2 by dt plus there is a resistor 1 by R2 V2 plus there is an inductor 1 by L2 V2 dt plus R1 is connected between V2 and V1. Therefore 1 by R1 V2 minus V1. L1 is also there. So 1 by L1 integral of V2 minus V1 dt equal to what? Already I have told you, that is equal to what? I of t. So these are the two equations that you will get. Okay. So I hope you have already drawn it earlier while I was drawing slowly. So these are the equations. Equation 7 and equation 8. So these nodal equations, equation 7 and 8, they are similar to what? Equation 3 and 4, which are the differential equations of mechanical system. So just write down these two equations. That's it. It's a small numerical problem. So it took a bit much longer time and compared to what I expected. I thought I will conclude this within half an hour, but it took more than half an hour. So you can mention in the chat box whether you have understood or not. If you want me to repeat any part of this lecture, any part which was not clearer to you, you just mention in the chat box so that I will repeat that only that portion of this lecture. Anyone? You can mention in the chat box any part if it was not clearer to you. If you have understood, just mention that in the chat box whether you have understood or not. And I will conclude this. You can write down the last statement. If you are noting down in your notes, you just write down the last statement. It is observed that the node basis equations 7 and 8 are similar to the differential equations 3 and 4 governing the mechanical system. Okay, so someone have mentioned it is clear and you have understood it. That's it. So thank you for watching this video.